How do we get downforce? Well, we have several different devices. We have a good downforce system that we call mechanical springs, shown here. These are heavy-duty springs. I can set them to 0, 125, 250, and 400 pounds for each row. And these are very reliable systems, and they are set once per field usually, and off we go planting. So that's a good downforce system. Our better downforce system is called pneumatic downforce. This air bladder you see on the right is adjustable from one place, and that gives us infinite adjustments from 0 to 400 pounds of weight transfer. Now, please comprehend that that is weight transfer from the toolbar to the row unit. That is not pounds per square inch in the air spring you see right there. We also have the capability of having margin sensors. Shown on the screen in the center are margin sensors of a 24-row planter, and you see that we have 5 margin sensors on that particular model if we have SeedStar XP. Now, the best downforce system is called the individual row hydraulic downforce system. It is best because hydraulic is really good. It's faster. You get another 50 pounds of weight transfer. But it's the best because each row has their own amount of downforce. So what you can see on the screen in the center is that we have a target margin of 210, but each row has a unique amount of downforce to attain that 210 margin, and that's for each row. So if I had the margin screen up here, they would all say 215, but you can see on the screen that each row has unique downforce. This, of course, is associated with SeedStar 3 and SeedStar 4 equipped planters. So now let's talk about these downforce electric systems. And I call them systems because that applies to the SeedStar style in the cab as well as the mechanical system outside the cab. So let's start first with our standard pneumatic system. Now, this compressor in the center of your screen there is associated with SeedStar 2 or Computer Track 350 equipped planters. This is a nice system in that the little toggle in the center of the screen there lets you adjust the PSI in the air bladder, air spring there, and you can adjust it to your preference across the whole planter, one place to stop. Now, the gauge here on the lower left-hand side of your screen measures both in pounds per square inch, and it has a correlated scale to show you the amount of weight transfer. So it'll tell you that airbag has X number of pounds in it, but it is transferring a certain number of pounds from the toolbar to the row unit. Nice gauge, nice indicator. The next level up downforce system is called Integrated Pneumatic Downforce System. It too is associated with SeedStar 2, but it's different in that I can adjust this from the cab with the downforce target there of 230. So that 230 pounds of downforce target then is the amount of weight transfer, not the amount of pounds per square inch in that airbag there. Now, on the back of the planter is going to be a 5 or 10 gallon air tank shown on the right hand picture and a valve body with electric solenoids on top. Now, the compressor on the tongue of the planter shown on the left hand screen is larger than the one we showed you in the base system, but all that electric compressor's job is to put air in the tank. The valve puts air in the bag. And so that is what is done by the operator from the buttons in the cab. So now let's talk about our set point pneumatic downforce system. This is associated with SeedStar XP, SeedStar 3, SeedStar 4. The difference between in the integrated and the set point is that we have margin sensors. And those margin sensors are called gauge wheel load sensors on 3 or 5 or 7 row units on the individual planter. So now what happens is I'm able to get a feedback of how much margin I have if I have a set point system. Now, the top of the line is the active pneumatic downforce system. What we're able to do is set our target margin And what that does is the computer, not shown, will set our downforce to achieve that margin. So what we have to have is a air compressor on the back of the planter that is 12 times bigger than the one we had on the previous unit. And what that does is the gives us more volume in that twice as big tank also, so that when the computer is being adjusting the downforce much more frequently than us humans do, we have the air capacity to do that. So this is a nice system, and you set it and you keep driving. Speaking of setting things, let's talk about how to set planters for ideal margin. So what we're going to be doing is trying to attain that ideal closed seed trench you see there on the right that we took early in 2020 planting season. What we now need to understand is that if we're going to use set point, that the operator is in charge of adjusting our target downforce. So you can see the target sign there, and we're going to have a target of 90, and the actual downforce is going to be, now this is weight transfer, not PSI again. The operator needs to adjust that margin or the downforce target to make sure our margin target is being maintained. And that's what we're going to try to teach you now, is how to set your planter if you're using set point. Now, the operator's manual tells us to put a number in the downforce target of 75 pounds. All right, you got to start someplace, and that's a good place to begin. So with 75 pounds in my target downforce, we're going to make a pass through the field in normal conditions. Now, for now, we're just going to ignore the margin at a glance window because we haven't set that yet. So where do we look for that ideal seed trench? Well, I put a red rectangle around where the ideal seed trench lives, and you need to be inspecting. Well, it lives ahead of the closing wheels and behind the double disc openers, and so that is where you need to be looking for that ideal seed trench. So the pictures I've been showing you is with the gauge wheels raised, and so we could get a better picture of that. But that's where you need to be looking for that ideal seed trench. Now, as you make a pass through the field, get out and inspect that seed trench. You may have to add to the number. You notice we went from 75 to up to, and we have an average of 90 pounds margin. What we need to do is we just need to adjust our downforce until we get that ideal seed trench. Now we need to set our ideal margin. And so how we do that is when we have that ideal seed trench attained with our perfect downforce, what we do is the next pass through, we look at the average margin number here shown in the red square on the right. So in this particular case, it was 90 pounds of average margin. Now, we need to enter that into our target margin screen. Well, how do we get there? Well, what we do is for 5 seconds, we hold the margin icon in the lower left-hand corner of the screen. And when we do that, after about 4.5 seconds, the alarms and limits setup page appears. So now what we need to do in the target margin empty window there, we need to enter that average margin to center our target margin screen there. Now, if you leave the factory default settings of 75% high warning and 50% low warning, those two fields are automatically populated. But let's say you want 85% high margin, you would just type the number in there that you want. So let's just go with our factory defaults of 90 in the middle, 45 and 160. So now that we've set our downforce to attain our ideal seed trench, we can now trust our target margin window. So as we go through the field, if the screen looks like it does here, we're all good. We do not need to change our downforce. But look in the red indicator over here. If the bars go above the line, and then it indicates the gauge wheel load is above target margin, so we need to lessen or decrease downforce. Whereas if the bars fall below the center line, the gauge wheel load is below the target, and we need to increase our downforce. And so we humanly change the 90 number there to either a bigger or smaller number as conditions of the field change. And then without stopping, we can be assured we have that ideal seed trench back there on the planter, and we don't have to stop and look for it. Now, if you would like a system that does that for you, that's what active pneumatic downforce system does. What I explained earlier is the active system has a bigger compressor and a bigger storage tank, and what that does is it allows us to let the computer run the downforce and we'll just set margin. Now, we don't have to do that. There can be conditions where set point is still a preferred option, even with that big compressor. And so you would just not enable active downforce by leaving this box blank, and that would disable active. But most of the time, vast majority of the time, active pneumatic downforce is going to be just fine and the preferred option. Now, setting this is simpler, because now we're adjusting target margin, not target downforce. So very simple, you start with 75 pounds of margin. Then what you do is you would then get out and check your seed trench and adjust the number up or down until your seed trench is right. Now, the beauty of active pneumatic downforce is now you do not have to go to a second screen and change your target margin center line, because you've been doing that as you change your target margin number there. So it's a very simple system to set. Now, what's going on here? Well, if you, the human, are setting your target margin, who's keeping an eye on the downforce? That's what the computer's doing. Is the computer shows a number of downforce pounds that is putting on a average row to get the ideal margin that you've set. The next thing we need to talk about is our planters, or high-speed planters nowadays. I'm moving 7 feet, 12 feet, or 15 feet a second, depending on your planting speed. And all systems have a time that it takes for them to adjust. So the pause timer can be a very good friend if conditions are changing rapidly, and that happens a lot with the speed of our planters nowadays. So what we need to understand is that if your changing conditions are a football field or shorter, that means that active pneumatic downforce isn't going to have a chance to hit that target perfectly. So a better plan is to pause the active pneumatic downforce system as you're going through these changing conditions. So keep that in mind. That will make your planting be more accurate. What we're going to now is show you a simulated planting scenario. You can see here that we are utilizing wooden blocks. We're going to have a 2x4 that is pushing up on the double disc openers. We also have wooden blocks underneath the closing wheels. But what we're going to do in a controlled environment is we are going to be adjusting the up force on our double disc openers so that we can show you how the monitor reacts to that. So when we watch the video in the next section, what I want you to be monitoring is row 11, because row 11 is the one we have our 2x4 pivoting system under. So let's watch this video and see how up force affects our display. We are going to simulate downforce and margin in a laboratory setting. Please remember that the purpose of this video is only to monitor row 11 on the screen, because that's the only one we have the 2x4 setup in. So as we start the video here, what I want you to comprehend is right now I actually have excessive downforce, and that is because that is indicated by row 11's orange bar showing I have excessive downforce. Now, if that's what they all look like, I need to change that. So what I'm doing now is I'm standing on the 2x4 and I'm creating up force as though it was a hard soil. So what you've seen is I've gone from excessive margin to way low on margin. So the result that the operator should be doing is changing that target downforce and to where it gets back in the black as shown right here. So hopefully this video has helped you to understand that downforce and margin are correlated, and we hope that this information will help you attain better planting results in your planting season.